Hello everyone, this is assignment 21. This is the Kevlar question. So I've redrawn what you see on your question page and just want to point out a few things. So Kevlar is obviously extremely strong and there's a big reason for that. What you're seeing here are two polymer strands. So you have one here and one here. And the way they're set up with the functional groups is that the polymer strands are hydrogen bonded to each other. So you end up with all this cross-linking and making an extremely strong material. But don't let that distract you from the rest of the question, okay? So let's just kind of go like this. Focus on one polymer strand only. Just a few questions that you have to answer on this. What functional group? Which two functional groups come together to make that functional group? And then draw a balanced chemical equation for that. So first of all, go through, find your functional groups. Ignore over here because I just kind of left it. Here's one. Here's one. Here's one. Hopefully these jump out at you right away. Those are amides. Not, you can have all your notes in front of you for the final anyway, so you can look that up. There's an amide. Next thing is, how did that amide come together? And if you remember from the lecture material, an amide is formed from the reaction with a carboxylic acid and an amine. So, and it's condensation, so you're kicking out water. So go through, find your amides, and break it down. So each amide is the coming together right there. So I'm just gonna go through and I'm gonna cut it. This is a good exercise to do, and I should have probably drawn this other one out over here. So let's just chop that guy like that. Okay, so now you can kind of see the pieces that go together to build this polymer. So each one of these amides comes together. This piece here would have been a carboxylic acid, and this side over here would have been an amine. So here you can see you have one chunk that has the benzene ring and two nitrogens on either side, so two amines. Then you have one benzene ring and two carboxylic acids, or what are going to be carboxylic acids on either side. Benzene ring, two amines. Okay, so you can kind of see where it started to repeat itself. Here's a repeat of this one up here. So what you're seeing is the amine one, carboxylic acid one, amine one, then you can have another carboxylic acid one, okay? So really, our repeat unit involves two chunks that we're seeing here. So one with the two amines on it, one with the two carboxylic acids on it. When you're recreating this bond or breaking down this bond, you're adding water back into it. So think about that when it's happening. So in this case here then, write out a water. There, and I'm keeping the OH together. So part of it's going to go on that side, and part of it's going to go on that side. So I'm going to erase some stuff here. I'm just going to erase this bottom one for now. Don't need that. Okay. Now, let's put this back together as its own monomer. I'm going to draw out the benzene ring. We had some nitrogens. We had an H there. We had an H there. Now this back together, you're adding an extra H onto each side, right? So you're recreating that amine. So there's one of the monomers. The other one is going to come from here. To draw out the benzene ring, you had this, okay, put a C, you don't have to put the C on there. Draw it however you want, like that. So we had that, right? If we just broke it down, then remember we're adding an OH back in to turn this into a carboxylic acid. Okay, so there's the other monomer. So in terms of answers to the questions, the first one we answered is an amide. The second one, what two functional groups? We have an amine and a carboxylic acid. And that last question is now draw the balanced chemical equation for this. So here we've shown both monomers. Now I will erase up here, so I don't need this anymore. And we want to put this guy back together. So yes, my arrows are kind of going all direction, but you guys can straighten this out on your pages. Two monomers, amine, carboxylic acid. you want to remove water. So just like what we just did, we put water back in. Now let's take water out. So you're taking that chunk out like that. You're going to lose some water and put it together just where you've chunked those two together. So you have an N, C. I'm going to write it out stickwise like this. Actually, it really does not matter if you put your NH up or down, however you want to put it, okay? And then you had a benzene ring over here, benzene ring over here, H's, and over here you had acetyl bond O, OH. Okay, so here's just showing you two monomers coming together. So it looks like we've just put two things together, but we can show now that this is going to be the repeat unit. Actually, I'm going to straighten this out a little bit just so it's easier for you guys to see. H there, and then put that H there. Remember that repeat unit? We drew it, or we had our Kevlar drawn on our pages, and you started to cut things down. What you did to form this, you kicked out one water. You're pretty much kicking the water out from the ends as well. It's going to keep growing and growing. So go along, put your brackets where you would have lost that part of the molecule, and over here too. You're going to lose that OH. There's your water that's being lost. Little N right there. To finish this up, you had to add N of those. Put that in front. N of those. Now it's how many waters were kicked out. One right here to form that initial bond. And two, because remember, every time this now goes to another one, you've lost another water, okay? So, and you don't even have to draw those on there. You can have those left off. That's completely fine. Okay? That would be perfectly valid. That's another water. So you've actually lost 2N worth of water. This is the same mechanism and the same thing that happens with amino acids making proteins. And I think you had a question like this on the practice final that we gave you guys. So the same thing, it's a condensation reaction between an amine and a carboxylic acid to make the amide, which is also known as a peptide bond in the proteins. In that case there, within the same monomer unit, you had a carboxylic acid and an amine. You only had one monomer that kept reacting with itself. In this case here, you have two monomers, then they keep reacting with themselves. So your repeat unit happens to have two monomers in it. Hopefully that helps.